So the first thing we're going to look at is arithmetic sequences and series on the checklist. Now the key differences in this topic is you need to be aware of the difference between D and R. D is the difference and it can be plus and minus, and R is the ratio. If the sequence is getting bigger, it's going to be bigger than 1. If the sequence is decreasing, it's going to be smaller than 1. Remember, if something is getting 10% bigger, you need to add 10% to the original 100%. So that would be R is equal to 1.1. The next thing we're going to have a look at is finance. Now with finance, you've got something which is really important, which is when you have your final value and your initial value, which is above the PMT here, you're often going to have the final value equal to 0. So if you're trying to pay off a loan, this will always be equal to 0. But if this is not equal to 0, you're always going to have a contradiction in signs. This one will be positive and this one will be negative, or this will be negative and this will be positive. If you don't do that, you'll get an error in your calculator. The next thing I'd like to talk about is inverse functions. So the most important thing with inverse functions is that you don't necessarily need to be able to rearrange them, but you need to understand how to draw them. So if you have a function like this, then an inverse function is going to go as a mirror image to the original function. And how does that work in terms of coordinates? Well, I haven't drawn this accurately, but let's say this coordinate here is going to be 1 minus 1. Then the corresponding one is going to be minus 1, 1. So this coordinate here would be minus 1, 1. Another really important thing to do with this is domain and range. So if you have h of x is equal to 2, so if you've got the range of a particular function, which is the y value, is equal to 2, then when you do the inverse, which is h minus 1 of x is equal to y, then we're going to replace the position of the 2, which means the 2 goes here. So remember, the flipping process on the coordinate axes also happens when you're dealing with the algebraic function as well. So next topic I'd quite like to go over is exponentials. So exponentials, you're typically going to have a question like this. The question will often ask what's going to happen when time is 0. So when time is 0, that's at the beginning of the process. So that is just substituting in x is 0. Another way of thinking of when x is 0 is this particular part of the graph, which is clearly going to be what the y-intercept is. Now, for a exponential graph, we're going to have something like this: y equals ab to the power of x plus c. Now, unusually for this topic, which is unlike any other function that we've dealt with, your y-intercept is always going to be a plus c. So you can either substitute in x is 0 and do that manually, or you can just literally calculate the value of a plus c. Later on in these questions, they will also ask you what is going to happen as the function levels off. And this is going to be the asymptote. And remember, the asymptote is always going to be c. So whatever the value of c is in the equation, that is going to be the value this line will tend towards but never quite touch. So if we go over trigonometry, remember trigonometry and questions are normally really challenging. So spend some time studying the diagram and working out what you're supposed to do. And if all else fails, you need to guess certain things. So clearly we're going to have two major different types of triangles. So let's say we've got a compound problem like this, and we've got, let's say we know what this angle is, we know this side, we know this angle, and it wants us to work out what this side is. This is a typical sine rule. Why? Because we have two pairs. So you use sine rule, but with the side on top. So it would be A, with this being A, sine of A equals b, with this next side being b over the sine of b. And actually, stereotypically, I would label the side we want as a. So you could actually switch these two pairs round so they're labelled differently. And then obviously you want to find out what lowercase b is, or the missing side. So to find the missing side, you just do sine of capital B, close the bracket, times a divided by sine of a. Remember, when you're doing this on the calculator, do it in little steps so that you're not making a mistake. And then you might get onto this problem, and then this might be given as 7 and this might be given as 4, and it wants you to find out what this question mark is. Now, if you were to find out what this question mark is, this time it's going to be the cosine rule. Why? Because sine we generally think as pairs of information, and then the cosine rule we think of side, 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 if we want to find a missing angle, or SAS, S-A-S. So we've got the top one is going to be the sine rule, and then the bottom two are going to be the cosine rules. So then obviously with the cosine rule, depending on which one we want to do, we make that letter the subject. So because we want to find an angle, we are going to deal with the one which starts with cos of A. So in your formula booklet, I'm not going to write it all down here, but you're going to use the cos one, which in this one here is this particular formula, cos of C. And remember, you can relabel the triangle to match what you want. So let's say, for example, we wanted to call this particular angle B. Well, then this would be the cos of B formula, which means wherever you have a C, you need to replace it with a B, and wherever you have a B, you replace it with a C. Another thing you can do is, if you don't like the letters in the diagram, you can relabel the letters in the diagram. Next thing, angles of depression and angles of elevation. These are all to do with Z's. So if we've got a Z angle, the angle of depression and elevation is the following. So this is the angle of elevation because it's the angle looking up from the ground, and then the angle of depression is going to be the opposite angle, or the alternate angle, which is this one here. So I'm going to label that with D, angle of depression. So it's always from the horizontal line, and it's the angle that it makes with the diagonal line. And then you can just form a triangle with that. Remember that these two angles are going to be exactly the same because they are what we call alternate angles. Okay, the next thing I'm going to go over is Voronoi. So Voronoi, I just call this a common sense topic. So if you're not sure what to do, just guess. Often you're going to have 4 sites. So the sites might be like this. And obviously the idea of this topic is to repeatedly do the same steps over and over again. They're not going to expect you to do this in paper, the first paper. So we are finding the midpoints, then we're finding the perpendicular bisectors, and then we're finding the equations of the lines that go through each pair of points, midpoints, etc. And then we're going to be finding what we call a vertex in the middle. Normally there will be something missing from the diagram, so there would be something like this, and it will say, what is missing from this diagram? Well, clearly we've got an edge missing. You can see that because you've got 2 sites in the same cell. It's a bit like saying we don't want 2 prisoners in the same cell, so you just need to work out the perpendicular bisector of this. Then at the end of a question, it will often ask you for the largest empty circle. What on earth does that mean? Well, typically, even though I didn't draw that then, we're going to have 2 vertices in the middle. So let's say we've got one vertex roughly here. And what I'm going to do is I'm going to move this red one here so it's a little bit more obvious where another vertex should be. So let's say we move the final site so it goes here. So we're going to say that these 3 points are equidistant from this green vertex here, and then we can do the same with this one. And then it will say, what is the largest empty circle? So for the largest empty circle, all you have to do is just calculate two distances. It literally doesn't matter which distance you calculate. Why? Because if you're calculating any two distances, this distance, we call this A, B, and C. A, B, and C, they're all going to be equidistant because these three sites all surround this vertex. Similarly, the distance A1, B1 and C1 are all equidistant as well. So all you need to do is you need to imagine three of the points surround one vertex, and then you need to imagine three of the points surround another vertex, and you just need to calculate one of the distances in this group, one of the distance in this group, and then you just need to compare with an inequality, and then let's say that these distances are bigger, you'd say therefore this creates the largest empty circle. We're now going on to probability. So with probability, one of the hardest questions people struggle with is the given question. So we're looking at, let's say, people studying Spanish and history. Let's say there's 7, 3 and 4 people in each of these parts of the Venn diagram. Let's say we're going to put 10 on the outside, and it says, given a person studies history, so let's say the question is, what is the probability that given they study history, what is the probability that they also study Spanish? So you need to basically zoom in on the circle. With a Venn diagram, it's really easy. We're literally just zooming in on this circle. It's narrowing the problem, saying out of all the people who study history, which is 7, how many people study Spanish? Well, it's